Hello dear students, we are going to learn the subject computer graphics and multimedia. Today we are going to learn the first chapter, that is Introduction to Computer Graphics. I am Aniruddha Vishwas, Assistant Professor, Department of Information Technology, JAS College of Engineering. Will be with you for the next upcoming online classes on computer graphics and multimedia. Today we are going to highlight on the following topics, starting with the introduction to computer graphics, applications of computer graphics, overview of computer graphics and graphic systems, display devices, input devices, output devices, and storage devices. So let's start. First, talk about the computer graphics. Graphics means representation of text, sounds, anything in a pictorial form, and that pictorial form could be like a graph, drawing, or any other way of representation that is easy to understand. Now coming to the definition of computer graphics, like it is an art of drawing pictures, lines, charts, etc. on computer screen by the use of a programming language which comprises of software techniques to create, store, modify text and picture, etc. This is an image you can see here, the computer graphics. Now, why computer graphics is used? There are a long list to understand why it is used. Now, in short, if we say a picture can be understood easily, just to represent many words or lines of texts in a single picture, so it is easily understandable. That is why computer graphics comes into picture, to represent a huge lines of text in a small picture. So that will makes our life easy, and that is how people can understand that picture or read it and find out the inner meaning of it. So that is easier representation of long text into a small part. Okay. Now this computer graphics is of two types. One is non-interactive or passive, and another is interactive computer graphics. And there is a two-way communication between computer and users that happens in interactive one. Now coming to the applications of computer graphics, there are huge number of applications that we can go through here. Basically in education and training. So in education, lot of sounds or words or lines of text need to be displayed. Instead, if we put some images, graphs, charts, etc. for better understanding, then it would be easier. But to create those chart, graphs and all, we need to have computer graphics. Okay, so the first field is education and training that is required. What are the advantages here? The fuel saving, definitely. The safety, ability to familiarize the training with a large number of the world's airports. So different applications are using the computer graphics. The first one is education and training. The second one, we can talk about the biology, because the molecular biologists often uses computer graphics to display the molecular structure and rotating the structure 360-degree in and out sight can be visible through the computer graphics. Then comes computer generated maps in vehicle or any GPS system that is being used in vehicles, where we use the computer generated maps for easier navigation. Then architect uses CAD design and vector images for better representation of different structure. Okay. Then comes presentation graphics. Basically presentation graphics using charts and graphs and pie charts, bar charts, etc., line graphs. So all these comes under the presentation graphics, which are very much familiar to the different business presenter. Okay, they use this computer graphics system for presentations. Coming to the next one is computer art. Digital art is done through this computer art and graphics. In entertainment like movie making, music, then television shows, some motion pictures, everywhere in every entertainment sector, computer graphics are now commonly used. Then the visualization. It is used for visualization of scientists, engineers, medical personnel, business analysts for the study of a large amount of information. Obviously, different educational software being used. Then in printing technology like 3D printing or normal printing like 2D printing or textile design, we use the computer graphics. Now let's describe the graphics system. There, there are a few objectives. First, to describe how color CATU works. Then coming to the next part where we'll describe and distinguish raster and random scan display along with various display devices. So first of all, we'll put light on cathode ray tube. Now what a cathode ray tube is, a very old way of displaying images and videos, is the technique that is called cathode ray tube. Okay. In the cathode ray tube, basically the most important thing is the electron gun, which emits a beam, and that beam of electrons that falls on a phosphate layer, phosphorus layer that we can say, and that is the screen made of. So on the phosphorus coated screen, the electron gun emitted beam falls on, and that is how the phosphor emits a small spot of light. So that particular portion of the screen get visibility. And if we draws the picture by directing the electron beam back over the same screen points quickly. Now look at this particular CRT, and here this is the connector pin, then the base which is holding the electron gun, which is very important part, playing the important part here. So the next part is the control grid voltage. This part controls the emission of the beam, electron beam from the electron gun, and it directs towards the screen, and the direction is controlled with the focusing system that helps to focus the beam on a certain portion of the screen, and that is phosphorus screen. So to put the beam on a particular location, not only this focusing system works, but also for doing the deflection from left to right or top to bottom, that means horizontal or vertical way. This Y deflector and X deflector, they helps the beam or guide the beam to be put on a particular location on the screen. Now on the screen, the illumination of the screen dots are controlled by this emission of beam from the electron gun, which is intermediately controlled by focusing system as well as the X and Y deflector, and as well as the control grid voltage. So here this pointing of dots on the screen or creating the illumination dots on the screen is done in two different ways. One is random scan, another is raster scan. So in the coming slides we will discuss about these two, starting with the first one, that is just raster scan. So across the screen the electron beam is swept. That means if this is the screen in raster scan, horizontally every line is getting scanned, right? One row at a time from top to bottom. So as the electron beam moves across each row, the beam intensity is turned on and off, because everywhere we need not to illuminate the screen, because the picture that we want to draw, sorry, maybe like this triangular, and every line is getting scanned horizontally, and the horizontal lines on which the image lies, so that particular point is getting illuminated, means the intensity of that particular point where the image is there on the scanning line is high, and where there is not the image lying there, the intensity is low. So this portion, it is having high intensity, and there where the image is not there on the screen, so there the low illumination will be there, so the beam intensity will be lesser. Now picture definition is stored in memory area, which is called as refresh buffer or frame buffer, right? And each screen point is referred to as a pixel, and which is in short called pel. So this particular screen, which is in the rectangular box, every point on the scanning line is called as a pixel. So the pixels are like this, dots like this. So every dot is scanned which are on the line, scanning line, and that is the smallest part on the resolution screen or viewport. So at the end of each scan line, the electron beam returns to the left side of the screen to begin displaying the next scan line. So let's say this is one line. So next time the starting scan starts from the next line. So let's say this is the next line. So in this way it will keep on scanning the lines, and the illumination beam intensity is keep on changing. Where the image should be, there the intensity is high, and where the image is not, there the intensity will be lower down. So this is the way how the raster scan works. If we see here from left to right, these lines are there, okay, and it retraces back to the left side, and again it starts scanning the line, and so on and so forth. So this is the way how the raster scan works. So retracing is done, and this is the way. And when it needs to come back to the initial location of the entire screen, then it retreats back in this way and reaches to its initial position. So the scan line is this one, and then horizontal retrace is this one, and the vertical retrace, when it reaches the end of the screen, then it comes back through this line. So this is vertical retrace. This is how the raster scan works. Now let's talk about the random scan, and after that we will also discuss about the difference between random and raster scan. So here random scan is, it is also called a vector display, stroke writing display, or calligraphic display. Basically here the every pale or pixel is not scanned like raster, but the gun is putting the light on the screen exactly the position where the image should be. So if we look into the picture here, so this is the final image, the triangle, let's say, and the electron gun is completing this is number 1, let's say, this is number 2, this is number 3, and this is number 4. So number 4 is the final. So here this is the final image after random scan. So from this particular point, this random scan or vector scan starts drawing. So the line is completed like this, then moves upward, then coming backward. So this is the way how the random scan or vector scan works, and finally it creates the image that it's supposed to. So here we can tell that it is a stroke writing display. It is not scanning the entire screen pixel by pixel or horizontally, but it only affects those particular pixel points where the drawing or the display file or display image is there. So random scan displays are designed to draw all the component lines of a picture 30 to 60 times each second. Okay, so after raster scan and random scan, now we'll also talk about various display devices like flat panel display, having two categories like emissive displays and non-emissive. Emissive, we can say flat panel emissive LED display, or non-emissive like LCDs. So where the electrical signals are converted into some lights, and that causes the image to be displayed. So first one is the plasma panels, also called the gas discharge displays. It is also emissive. Then thin film electroluminescent displays, then light emitting diodes, and liquid crystal displays. So these are different display devices that is our concern. Now the question is that before these kinds of display there were CRT or cathode ray tube display, and that was very heavy and low cost but heavy weight and slow as well. But LED, LCDs and other thin film electroluminescent displays, they're very first lightweight, little expensive, but the image quality is very high in this kind of display where emissive and non-emissive displays are there. Now coming to the display, after display devices there are input and output devices as well. So starting with the keyboard, we all know that we are using 101 number of keys, QWERTY keyboard, and that is basically used for entering input in text form or in character form. Then comes to the concept of mouse, which is we can say the movement of the mouse can be of two dimensions, left, right, and front, back. Joystick is also similar to that, but a little different. I will show you the pictures afterwards. Then light pen, also an input device. Trackball, scanner for scanning different important text or any other files. Then graphic tablet, that is also a kind of input device. The microphone, magnetic ink card reader, OCR, barcode reader, OMR, all these we will discuss one by one. Keyboard 101 or 102 keys keyboard. Then mouse, it also gives us a pointer kind of thing to point a particular text or any point of display location, to point it out or to draw some line or do some figure, etc. So that is called a mouse. Basically it is required to point out something on the screen, right? It cannot be used for writing anything. Then comes joystick. It is also kind of a mouse, but a spherical ball is attached to it, and only two-dimensional movement can be possible. Then comes the light pen. It is also a pointing device. Tip of the light pen is moved over the monitor screen and the pen button is pressed, then we can write something on the display device using light pen as well. Then trackball is an important input device, which is mostly used in notebook or laptop computer instead of mouse. And then comes the concept of scanner, which is used for when some information is available on paper and it is need to be transferred in a soft copy in a hard disk. Then we use scanner here, and this is scanner. And then digitizer, microphone, and magnetic ink. You all know all these things. MIC here, basically magnetic ink character recognition. The main advantage of MIC is that it is fast and less error prone. Okay. Then coming the optical character reader. It basically OCR, input device used to read a printed text. Fine, OCR. Then comes barcode reader, which is a device used for reading barcoded data. Then comes the optical mark reader. OMR is a special type of optical scanner used to recognize the type of mark made by pen or pencil in a bubbles inside, whether it is filled or not filled. And basically those are being used in competitive exam evaluation. Now we'll talk about the output devices. While talking about the output device, the first one comes in picture is that monitors. And are of two types. One is CRT, cathode ray monitor, and a flat panel display. The cathode ray monitor is large in size and high power consumption is there, and weight is also huge. And basically it displays 80 characters in one line horizontally and 25 lines vertically. So that is the cathode ray tube. Then comes the other output devices like emissive display devices, non-emissive. So before that we need to know about the flat panel display monitor. So CRT is not a flat panel but a little bit convex, and we cannot hang them on the wall, but the flat panel displays we can do it. And these flat panel devices are of two types, emissive display and non-emissive display. If we give example of emissive, then we can say it is a light emitting diodes, LED, plasma panel, etc. are example of emissive. Basically emissive display devices, it convert the electrical energy into light. So that is the main concept of emissive display device, converts the electrical energy into light. And if we convert it into light, then it's easily possible to demonstrate one picture using light intensity. Then come to the concept of non-emissive displays, which is used optical effects to convert sunlight or light from some other source into graphics patterns. Okay. For example, the LCD liquid crystal device, it basically uses the optical effects to convert sunlight or light from some other source into graphics patterns. So from light to graphics, and in emissive, it is electrical energy into light. So that is the thing. Now we are also left with printers, which is also an output device, and that is used to print information on paper, hard coded output we can say. And that is of two types. Two types of printers are there. First one is impact printer, and the other one is non-impact printers. Okay. So if we talk about the impact printers, the dot matrix, the daisy wheel, and the line printers, these are the impact printers. And if we talk about the non-impact printers, the examples are like laser printers and inkjet printers. Now the difference between the impact and non-impact printer is that impact printer is a little cheaper, slower, and direct impact with the paper for printing. But non-impact printer is no impact for printing, and it's less noisy, and it is non-impact printers are little costlier than not little costlier, much costlier than the impact printers, and mostly these are being used non-impact printers for sophisticated use, where the quality of printing is highly or given importance most. The laser printer takes less time to print a page, but dot matrix, daisy, or line printers, they consume much more time to print one paper, one A4 size or whatever size paper. But laser printers takes less time, consumes less energy, and the cost is higher. So the thing that is higher is cost, but speed is fast. That means the speed or the velocity of printing is higher. Okay. Now coming to the storage devices, basically the cache memory, the main memory, and the hard disk. These are the three types of storage devices that our computer systems actually having. So in computer graphics, everything that we can store either in cache memory, primary memory, or secondary memory, depending on the processing requirement. So starting with the cache memory, which is a very high speed semiconductor memory, can speed up to the speed of CPU because it is very much synchronous with the speed of the CPU and much faster than the main memory. And it acts as a buffer between the CPU and the main memory. It is used to hold those parts of data and program which are most frequently used by the CPU. That is why it is called cache. The parts of data and programs are transferred from the disk to the cache memory by the operating system, and from where the CPU can access them. So what are the advantages? Are as follows. Like cache memory is faster than main memory, that we all know. It consumes less access time as compared to main memory, and it stores the program that can be executed within a short period of time, and it stores data from temporary use. Okay, but there are some disadvantages, like cache memory has limited capacity because it is very costly. Yeah, that's why it comes with less amount of storage. So those are the two disadvantages. Now coming to the concept of main memory or RAM, random access memory. Primary memory holds only those data and instructions on which the computer is currently working on. So that is called the active data set is only stored on the RAM. Okay. Basically there are different buffered area for storing different graphical data. Okay. and it is generally made up of semiconductor device. These memories are not as fast as registers, and the data and instruction required to be processed resides in the main memory, and it is divided into two subcategories. One is RAM and another is ROM. Now coming to the characteristics of main memory. If we talk about the main memory, this is the semiconductor memory, and which is known as main memory, and usually volatile in nature, because if we switch off the computer, then all data will be lost, and it is working memory of the computer and faster than secondary memories. That means the RAM is faster than hard disk. A computer cannot run without the primary memory. That's true. Now coming to the concept of secondary memory, how it looks like. It's the hard disk. It contains different platters and it is cased by a harder coating. Okay, different companies produces these hard disk drives, and this type of memory is also known as external memory or non-volatile memory. That means even if the switch off the computer system, the information stored in the secondary memory is always stored safely until and unless there is a system crash. So CPU directly does not access these memories. Instead, they are accessed via input-output routines. The contents of the secondary memories are first transferred to the main memory if we need to process them, and then the CPU can access it. For example, the CD-ROM and DVDs, etc. Now let's talk about the characteristics of this secondary memory. There are magnetic and optical memories. It is known as the backup memory. It is a non-volatile memory and permanently stored even if power is switched off. And it is used for storage of data in a computer, and computer may run without the secondary memory, and it is slower than primary memories. So to summarize everything in this particular chapter, first we talk about what is a computer graphics system, why we use it, what are the applications of it. Then comes the overview of the computer graphics system. Then comes with the discussion on the display devices of computer graphics, then input output devices, and finally the storage media. So thank you all the students. Hope you will come and enjoy my next online computer graphics and multimedia classes. Have a nice day.